A lot of people don't fail data engineering interviews because they are bad technically. They fail because when the interviewer asks the question, they panic. They start listing tools, they define random terms, and never actually answer the question. And that's what actually kills them. So let's fix that. Hello everyone, welcome to Big Data Effect. I am Pranit and I have 4 plus years of experience working as a data engineer. So in this video, I am going to run a mock data engineering interview with 4 realistic questions. They are a project explanation question, one SQL question, one Spark performance question, and one AWS pipeline debugging question. And I am not just going to give you the answers. I will show you how to answer in a way that sounds like an engineer, calm, structured, and real. And stay till the end because I will give you one simple answer framework you can use in almost in any data engineering interview. So that if someone asks you a SQL question or a Spark question or asks you to explain your project, you don't sound like a confused documentation page. Now let's go to the most underestimated question in data engineering interview, but this decides your impression. Can you walk me through one data engineer project you built end to end? This question looks easy, but it's not. A lot of candidates destroy themselves here by saying something like, I used Spark, AWS, SQL, and Airflow. That's not a project explanation, that's a tool list with confidence issues. A strong answer needs structure. Here's how I would answer. I worked on a batch data pipeline where the source data came from APIs and log files. We landed the raw data into S3, then used Spark to clean and transform it into curated datasets. Those curated tables were then consumed by downstream BI reporting. That already sounds much better because the interviewer can see the flow. But don't stop there. You want to keep going in this order. Source, ingestion, processing, storage, orchestration, and reliability. So I would continue. The pipeline was orchestrated using Airflow, and one thing we had to be careful about was safe reruns and partial failures. So we made the processing steps as idempotent as possible and added checks around row counts and job status to catch issues early. Now it sounds like a real project. And if you want to make it even stronger, mention one challenge. One issue we had was delayed source data. So we needed the pipeline to support backfills without duplicating downstream records. That single line adds maturity. Because real projects are not, I built X. They are, I built X and here is where I got messy. That's what interviewers trust. So what are they testing in this question? They want to know, can you explain a system clearly? Do you understand the full data flow? Have you dealt with reliability issues? Do you sound like an owner? If your answer has no movement and no orchestration and no challenge in it, it often feels like shallow. Question 2. SQL scenario. Imagine the interviewer says, you have an orders table and a payments table. One order can have multiple payment attempts. I want the latest successful payments per customer and I don't want duplicate rows. How would you solve it? Now this is a very realistic interview question because it's not testing whether you know select. It's testing whether you understand grain, deduplication and join traps. Here is how I would answer. First, I would clarify the expected output. I would say, before writing the query, I want to confirm the output grain. Do we need one row per customer or one row per customer per order? And when we say latest successful payment, are we using payment timestamp as the ordering field? That already makes your answer stronger because most candidates rush straight into writing code. Then I would continue. If the goal is one latest successful payment per customer, I would first filter only successful payments, then use row number partitioned by customer and ordered by payment timestamp descending, then I would keep only rank 1. And if I also need order information, I would join that filtered result back to the orders table carefully. That word matters carefully because this is where people mess up. They join raw tables too early, create duplicates, and then spend the rest of the interview trying to explain why their row counts exploded. A better way to say it is, I would reduce the noisy side first, then join. That sounds like real engineering thinking. And if you want to sound even stronger, add this. If there is a chance of equal timestamps, I would define a tiebreaker using something like payment ID. That tells the interviewer you think about edge cases, not just the happy path. Now what are they really testing here? Not SQL syntax. They are testing whether you understand output grain, ranking patterns, duplicate creation, and safe joins. So remember this. Good SQL answers should sound like design decisions, not just queries. Now let's move to Spark. The interviewer says, Your Spark job is stuck at 95%, and one task is taking much longer than the others. What do you think is happening, and how do you debug it? Now, this is a beautiful Spark question because it sounds simple, but it immediately separates the people who have worked with Spark from people who just memorize the definitions. A weak answer sounds like maybe memory issue, maybe cluster issue. A strong answer starts with hypothesis. So I would say my first suspicion would be data skew. Because when one task takes much longer than the others and the job is struck near the end, it usually means one partition has significantly more data than the rest. That already sounds much better. Then I would explain why. In Spark, work is divided across partitions. If one key has a huge amount of data, then other partition becomes much heavier, and one task ends up doing far more work than the others. That's why the job looks almost complete, but one task keeps running. That's clear. Then I would move into debugging. I would open Spark UI and check stage level details, task duration, input size, shuffle rate, and whether one task is clearly an outlier. I would also look at whether a join or a group by happened before that stage because those operations often expose queue. That sounds real. And if you want to level it up, add possible fixes. If skew is the issue, possible fixes would be choosing a better partition strategy, salting heavy skewed keys, checking whether a broadcast join makes sense, or using adaptive query execution if the environment supports it. Now the interviewer hears three things. You know the symptom, you understand the cause, and you know practical fixes. That's exactly what they want. And here is where many candidates mess this up. They start by defining Spark and what it is. That's not the question they ask. The question is not what is Spark. The question is, can you debug a Spark problem? That's the mindset shift. So what they are testing here? They are testing partitions, shuffle awareness, skew, Spark UI thinking, and performance reasoning. That's why Spark interview answers should usually follow this order. What might be happening, why it happened, and how would I fix it, or how would I debug it? This answer structure works really well. Now let's do a AWS scenario. The interviewer says, your data lands in S3 every hour, but downstream dashboards keep getting delayed. How would you debug this pipeline on AWS? This is a great question because it sounds like an AWS question, but it's actually a pipeline debugging question. A weak answer sounds like, I would check glue, maybe EMR, maybe logs, that feel random. A strong answer starts with structure. So I would say, first, I would break the pipeline into stages, ingestion into S3, processing, and downstream consumption. Then I would check where the delay is actually happening rather than assuming AWS itself is the problem. That already sounds more mature. So I would go layer by layer. For S3, I would check whether files are arriving on time, whether partition paths are as expected, and whether the file layout is causing slow reads, especially if there are too many small files. Then, if processing runs on Glue or EMR, I would check job runtime history, recent failures, retry behavior, and whether there is any spark queue or partitioning issue increasing processing overtime. And then for IAM, I would verify permissions only if there are access related failures, because IAM issues usually fail loudly. Delays are more often caused by data layout, orchestration timing, or slow processing. That line sounds experienced. And finally, I would also think about cost and design quality. Because poor partitioning, unnecessary processing, or badly designed reads can increase both latency and cloud cost. That's the senior signal. Because now you are not just debugging, you are thinking like someone who owns the system. So what they are testing here? They want to know, do you debug in layers? Do you understand S3, processing, and IAM practically? Can you connect performance and cost? That's what a good AWS data engineer should sound. Now let me show you where people actually fail in interviews like this. First, they answer too fast. The interviewer asks one thing and they respond with five unrelated things. Slow down, clarity first, then answer. Second, they define instead of reasoning. If I ask about Spark's queue and if you only give me definitions, that's weak. A strong answer is why is it matters and how would you handle it. Third, They mention tools instead of decisions. Use it Spark, Airflow, AWS is not a strong answer. Use it Spark because the data volume was large and distributed processing was necessary. That is a strong answer. Fourth, they don't mention trade-offs. Good candidates say things like batch versus streaming, broadcast versus shuffle join, small files versus better partitioning, reruns versus idempotent design. That's what makes your answer believable. So here is the one framework I want you to take from this video. For most data engineering interview questions, answer in this format: what, why, and how. What is the concept or the approach? Why does this matter in this case? How would you apply it, debug it, or optimize it? For example, what is shuffle? It's redistribution of data across partitions. Why does it matter? Because network and disk are involved, so it becomes expensive. How would I handle it? I would reduce unnecessary wide transformations, choose the right join strategy, and validate partitioning. That structure is simple, and more importantly, it makes you sound calm, and calm sounds competent. So let's wrap this up. If you want to do well in a data engineering interview, don't jump into answers without clarifying. Don't sound like a glossary. Explain systems as flows, not just like a tool names. Talk about trade-offs and practice saying answers out loud. This is the part people skip. They prepare silently, then they freeze in the interview. Interviews are not just knowledge tests, they are also communication tests. And that's why mock interviews help so much. If you want, come and mock, and I will make part 2 with more scenario based questions, maybe PySpark heavy, Airflow heavy, or SQL only. And if this helped, subscribe. Because I am turning this into a real data engineering interview series. Mock interviews, real interview experiences, preparation plans, resume fixes, and practical breakdowns. And if you want to prepare for questions like this practically, watch the next video. I already broke down how to prepare for Spark, SQL, and AWS interview rounds step by step. We'll meet in the next video. Till then, bye bye.